Today, we are breaking down one of the most fundamental, most powerful ideas in all of programming. Seriously, it's the secret weapon that makes everything from your favorite app to massive, complex software even possible. So let's just dive right in and see how this all works.
You ever look at a huge app, something with millions of lines of code, and just wonder, how does that not collapse into a total chaotic mess, right? How do developers keep it all manageable, organized, and running smoothly? Well, it's a great question, and the answer is actually pretty elegant.
See, the secret is they don't build one giant monolithic thing. Instead, they build software out of small, intelligent, and reusable pieces. You can almost think of them like superpowered Lego bricks, where each little brick has a very specific job to do.
And the most crucial, the most fundamental, the most important building block of them all is something called a function. And let me tell you, understanding this one concept is pretty much the key to unlocking how all modern software is built.
But okay, before we can really appreciate what a function is, we have to understand the problem it was designed to solve. And that brings us to a core principle in software design: modularization.
Now, modularization sounds like a fancy word, but it's really just about breaking a big problem down into smaller, bite-sized pieces. So instead of one gigantic script, you create these little independent modules. And the benefits here are just huge. It makes your code way easier to read, much easier to debug when something breaks, and it lets whole teams of developers work on different parts at the same time without stepping on each other's toes.
Okay, so theory is great and all, but let's make this real. To really get what a function does, we're going to use what I think is the perfect analogy: a simple coffee machine.
Just think about it for a second. A coffee machine is this perfect, self-contained unit. It's designed to do one thing, make coffee, and do it perfectly, every single time. You don't build a new machine from scratch every morning you want a cup, right? No way. You use the same reliable tool over and over. That is a function.
So, let's pop the hood on our function coffee machine and see how it actually works. It all comes down to three really simple stages: input, process, and output.
So first, you provide the input, right? You tell it you want a large espresso. Then you call the function, which is just like pressing the start button. Then the machine runs its internal process. It grinds the beans, heats the water, all that magic you don't even see. And finally, it delivers the output, a perfect, fresh cup of coffee. That simple flow is exactly how a programming function operates.
Now let's map that to the real terms. Those inputs, the coffee type, the size. In programming, we call those parameters. They're the specific instructions you give the function so it knows exactly what you want it to do.
And what about that hidden process inside the machine? Well, that's called the method body. And this is such a brilliant example of a key concept called implementation hiding. You don't need to know the engineering of a coffee machine to use it, right? You just trust that when you press start, you get coffee. All those messy details are hidden, which keeps things simple for you, the user.
And finally, that amazing cup of coffee you get at the end, that's the return value. It's the result, the final product that the function hands back to you after it's done its job. So you see, input, process, output, parameters, method body, return value. It's the same pattern. That's really the core of it.
But you know, basic functions are just the start. The real power comes when we start adding more flexibility and a little bit of intelligence. So let's see how we can upgrade our basic function to handle more complex situations.
So check this out. This is a concept called method overloading. Look at this setAlarm function. It's one name, but it kind of has multiple talents. You can give it just an hour, or you can give it an hour and a minute, or you can even add a custom label. The same function name is smart enough to handle different sets of inputs. This makes your code incredibly flexible and clean.
All right, next up, how a function handles its ingredients. This is super important. There are two main ways. With pass-by-value, you're basically giving the function a photocopy of your data. It can write on it, tear it up, do whatever it wants. But your original is safe and sound, totally untouched. But with pass-by-reference, you're giving it the keys to the original data. So, and this is the crucial part, any changes it makes are permanent. Knowing the difference here is absolutely key to avoiding some really sneaky bugs.
So we know what functions are, and we know how they work. But how do we build good ones? Well, for this, let's switch our analogy. Forget the coffee machine for a minute, and let's think about building a house. Okay, this right here, this is bad design. This is exactly what code looks like when it's not broken down into functions. It's one giant, chaotic room, trying to be a kitchen, a bedroom, and a bathroom all at once. I mean, can you imagine trying to fix a leaky pipe in the bathroom without flooding the bed? It's a total nightmare.
In the world of programming, this disaster has a name. It's called low cohesion, because that one room has no single focused purpose. And it's called tight coupling, because everything is tangled together. A tiny little problem in one area creates a huge mess absolutely everywhere else.
So the solution, obviously, is a properly designed house. Every single room has one clear job. That's high cohesion. The kitchen is for cooking, the bedroom is for sleeping. Period. And the rooms are independent but connected. That's loose coupling. You can completely gut and remodel the kitchen, and it won't affect the bathroom plumbing at all. This is what we're aiming for when we write our code.
So the main takeaway here is really simple. High cohesion just means your function, like a well-designed room, should do one thing and do it exceptionally well. If your function is called calculate sales tax, it shouldn't also be trying to send emails on the side.
And loose coupling means your functions are independent. Yeah, they can talk to each other, but they aren't hopelessly tangled up. And that makes your entire program so much easier to understand, to update, and to fix down the line.
When it comes right down to it, it's all about this. Functions aren't just some neat programming feature. They are the absolute fundamental building blocks for creating software that is clean, organized, scalable, and truly powerful.
So now you have the blueprint. You know the secret for turning total chaos into elegant order. You understand the most powerful tool for building clean, well-structured software. So the only question left is, what are you going to build?